Okay, let's get started. For question number one, we're asked to solve for x. Answers must be simplified proper fractions, simplified improper fractions, or integers. No decimals or mixed numbers. So, for the first problem, we can use cross products to help figure out the answer. So 7 times x is 7x, and that's going to equal 3 times 6, which is 18. To solve for x, we would divide both sides by 7, and you'd get x equals 18 over 7. That can't be simplified. So there you go, there's your answer. Sorry for the poor handwriting. X equals 18 over 7. All right, for the second problem, 16 times x is 16x, and that's going to be equal to 6 times 14, which I'll do over here on the side. 6 times 4 is 24, carry the 2. 6 times 1 is 6, plus 2 is 8, so 84. All right, at this point, we would divide both sides by 16. You get x is equal to 84 over 16. Well, 4 goes into both of these. 4 goes into 84 21 times. 4 goes into 16 4 times. So the answer is 21 over 4. All right, in questions 3 to 5, use the following table. The table shows a proportional relationship between x in minutes and y cost. What is the constant of proportionality for the relationship? So the constant of proportionality is determined by doing y divided by x. So it doesn't matter which one of these you do, but obviously this is going to be the easiest one. But let's just say you decided to do 8 divided by 1/2. That would be the same as 8 times the reciprocal of 1/2, which is 2, which is 16. If you try to do 16 divided by 1, you'd also get 16. If you do 40 divided by 5 over 2, 40 divided by 5 over 2 is equal to 40 times the reciprocal of 5 over 2, which is 2 over 5. Multiply, 40 is really 40 over 1. I would simplify 5 and 40 to get 1 and 8. Multiply across, you get 16 over 1, which is 16. So it doesn't matter which pair you divide, 8 by 1/2, 16 by 1, or 40 by 5 over 2, your answer is the constant of proportionality is 16. Write the equation that describes the proportional relationship using the format y equals. Well, if you recall, y equals our constant of proportionality times x. In this case, the constant of proportionality is 16, right? So it would be y equals 16. Oops. Y equals 16x. What does 5 over 2 in the table above represent? Well, it looks like when minutes is 5 over 2, which, by the way, 5 over 2 is equal to 2 and 1/2. Looks like the cost is $40. So 2.5 minutes cost $40. That makes sense. Let's see. 5.2 minutes, that doesn't make sense. It's not 5.2. 40 minutes cost $2.50. Nope, that's backwards. And none of the above is clearly not the right answer. All right, for number 6, we have, excuse me for a second. For number 6, we have Mrs. DeValue was cold and raised the temperature in her classroom. The following table shows a relationship between the temperature of the room and the time that passed in minutes since she raised the temperature. Is there a proportional relationship between the temperature and the number of minutes that pass? So we have temperature and number of minutes that pass. Well, let's see. After 2 minutes, the temperature was 68 degrees. After 4 minutes, it was 88 degrees. And wow, after 6 minutes, it was up to 122 degrees. That's pretty hot. So you can find the constant of proportionality. 64 divided by 2 is 34. 88 divided by 4 is 22. And 122 divided by 6, well, let's see. That would be 6 goes into 12. Well, let's do it this way. 6 goes into 12 2 times. 2 times 6 is 12. No remainder. Bring down the 2. So this would be really 0 times. 0 times 6. And you get 6 goes, we'd have, excuse me, a remainder of 2. So this is 20 and 2/6, or 20 and 1/3. Clearly not the same constant of proportionality in any of these cases, right? So no, it is not a proportional, not proportional. Right? Another way you could do it is if you do 68 over 2, is that equal to 88 over 4, right? You can try with cross products. Well, 2 times 88 is 176, and 4 times 68, 4 times 68, 4 times 8 is 32, carry the 3, 4 times 6 is 24, plus 3 is 27, so the cross products are not even close to each other, so this is another way of showing that it is not a proportional relationship. Okay, use the following graph to answer questions 7 through 9. The relationship between the distance in kilometers, x, and the total cost, y, is proportional. Okay. What is the constant of proportionality between y and x? All answers need to be simplified fractions, simplified improper fractions. No decimals. All right, well, this right here is the point 20, comma 8. 20 is my x-coordinate, 8 is my y-coordinate, right? So to get your constant of proportionality, you do y over x, which is 8 over 20, which can be simplified. 4 goes into 8 2 times, 4 goes into 20 5 times, so the constant of proportionality is 2/5. Next thing, what does the point 20, 20 comma 8 tell us? Well, x is also our kilometers, right? The distance traveled, and y-coordinate is our dollars, right? So 20 kilometers goes with $8, and that's essentially what we're saying. We're saying that 20 kilometers for $8. Not sure exactly what this is, the cost of a bus or something, who knows, but 20 kilometers for $8. Now write the equation that represents the relationship between y, the distance in kilometers, and x. The equation should be written in the format y equals. Well, remember, y is equal to our constant of proportionality times x. So y would equal 2/5, which we calculated here, times x. Y equals 2/5 x. Moving on, number 10. Is this a proportional relationship? Right. A couple of things that we can look at here. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. And when x is 4, y is 8. Right? So in each of these cases, if I take my y-coordinate and divide it by my x, 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is 2. And 8 divided by 4, let me make that look more like an 8, is 2. So yeah, it looks like a proportional relationship because the constant of proportionality is the same for every ordered pair. All right. Now, another thing that you can say is there's two things that every line, every graph of a proportional relationship has. It is linear, so is this linear? Yes, it is. Oops, linear. Let me spell that correctly. So 1, it is linear. Check. My handwriting's still bad. And 2, it passes through the origin. right, which is the point 0, comma 0. So does that pass through the origin? Check. So those are the two properties that a graph of a proportional relationship has. So clearly we've given 3 reasons why this is a proportional relationship. Moving onward, number 11. 10 bottles of water cost $10.45. Write and solve a proportion that would help determine how many bottles of water you can purchase with $54.34. So for number 11, we're asked to write the proportion only on the line, and the second part we are answering the question. So we are comparing bottles of water to the amount of money it costs in dollars. So 10 bottles goes with $10.45, just like how many bottles could you purchase? Well, we don't know how many, so we'll put a variable there. Goes with $54.34, right? So this right here is the proportion that we could write. That would go right there in that, on that line. Now, to actually calculate it, should have pulled up my calculator sooner. Right? Yes, you will be allowed a calculator on this assessment. There are times where it's useful, and there are times where it's not really useful. All right, so here we go. So 10.45 times x is 10.45x, and that's going to equal 10 times 54.34. Well, that would just move the decimal over, so it would be 543.4. Now, if I take my calculator and I divide both sides by 10.45, divide by 10.45, divide by 10.45, I would get x is equal to, all right, 543.4 divided by 10.45, x equals 52, which means you would be able to do, you would be able to get 52 bottles for $54.34. For number 12, 8 bags of candy cost $12.20. Write and solve a proportion that would help you determine how much it would cost to buy 6 bags of candy. Well, if we have bags of candy and we are comparing it to dollars, right? So 8 bags of candy goes with $12.20, just like 6 bags of candy goes with a number we don't know. So that right there is our proportion that would go on this line. Okay. Now, let's solve that proportion. Well, 8 times x is 8x, and 6 times $12.20, well, 6 times 12.20 is 73.2, or 73.20. Divide both sides by 8. So 73.2 divided by 8 is equal to 9.15. So x is equal to 9.15. So this would be $9.15, and it's kind of redundant to have the word dollars after dollars. So there you go. All right, next question. Mrs. DeVito has a second job working as a proportional cat groomer. That's kind of weird. That means she grooms cats at a proportional rate. Not DeVito, Mrs. DeValue. That makes more sense. I could see her being a cat groomer. Mrs. DeValue grooms 42 cats every 140 minutes. Which of the following could represent the number of cats she grooms and how long it takes to groom them? Well, if you think about it, 142 cats, right, divided by 140 minutes, 42 divided by 140 is equal to 0.3, right? So if I were to take 40 and divide it by 42 and divide it by 140, I get 0.3, right? And it's exactly 0.3. This is not 0.3 repeating. All right, so now I'm going to do the same thing. I'm going to take cats and divide it by minutes and see what happens. So if I have 101 divided by 303, I get 0.3 repeated. That looks like 0.3, but it's not the same because this repeats forever. All right, let's try the second one. 180 divided by 600, that's 0.3. I can have 36, divide that by 108. That's 0.3 repeated. Doesn't look good. I can also have 204 divided by 612. That's 0.3 repeated. 174 divided by 58. Oops. Ignore what I just did. I just made a mistake. 174 divided by 580. That's just 0.3. And 12 divided by 40. Sorry, my mouse is getting stuck. That's what happens when you tape something live. 12 divided by 40 is also 0.3. So which ones match the original? Looks like B, E, and F. B, E, and F. The others are close to 0.3, but the 3 repeats, so it's not the same constant proportionality. Number 14, how many proportional relationships are shown in the coordinate plane? Well, it's got to be linear and passing through the origin. So this one is linear and passes through the origin. This one is not linear and doesn't pass through the origin, so that is not proportional. And this one is linear and passes through the origin. So how many proportional relationships are there? There are 2. 1, 2. Not this one. Number 15. 5 bags of Swedish fish cost $4.20. Which equation will help you to determine how many bags you can buy with $7.56? So we're not even asked to calculate it. We're just asked which one is the same. All right, so we are comparing bags of Swedish fish to dollars, right? So I know that, let's see, 5 bags goes with $4.20, just like a number we don't know goes with $7.56. Now, you might have not have written the proportion like this, but it's okay because as long as we are consistent, bags to dollars, bags to dollars. If you wrote dollars to bags, that's fine too. You just need to make sure you're consistent where you're putting everything. So we want 420 times x and 5 times 756 in our cross products. So does this have 420 times x? Yep. Does this have 5 times 756? Yep. This looks like our answer. Let's see if this one has 420 times x. 420 times x? No. 420 times x? No. 420 times x? No. So only answer A makes sense. Let's do number 16. Use the following table to answer questions 16 to 18. The relationship between how many cookies a bakery makes, C, and the number of minutes, M, that the bakery is open is proportional. The table is incomplete. Complete the table. Well, it looks like 1 minute, 42 cookies are made. 2 minutes, 84 cookies are made. And in 3 minutes, how many cookies? Well, if I took 42 times 2, I'd get 84. So 3 times 42, 3 times 42 would be 6, 126. Looks like 126 cookies in 3 minutes, and that would be consistent because that would be 42 every 1 minute. Now, write an equation that represents a relationship between how many cookies the bakery makes and the number of minutes open. Right? The equation should be in the format C equals. Well, let's talk about it. I like to just say, well, M is one number while C is another. So when M is equal to 1, C is equal to 42. I use these two numbers because they're the easiest ones to work with. So 1 times C is 1C, and that's equal to 42 times M, which is 42M. So the answer is C equals 42 times M. Right? So it makes sense. 42 times the number of minutes. 42 times 1 is 42. 42 times 2 is 84. 42 times 3 is 126. There you go. What is the constant of proportionality in that table? Well, you really want to talk about in the formula, you think of this almost as y equals r times x, where r is the constant of proportionality. When we solve for c, the number that's multiplying our other variable, which is m, is 42, so 42 is our constant of proportionality. Moving on to numbers 19 and 20. Based on the information below, the total cost for various number of movie tickets is shown in the table. The table is incomplete. Based on the table, how many movie tickets could you purchase with $86.25? Well, let's take a look at what's going on here, right? For example, 17.25 divided by 3 is $5.75 per ticket. 34.5 divided by 6 is $5.75 per ticket. Looks like $5.75 per ticket is what we got. So $86.25 divided by 5.75 is 15 tickets. Looks like that's how many tickets you can get. And based on the table, what is the cost of each movie ticket? Well, we kind of answered that already when we divided the total cost by the number of tickets. It was $5.75. And I just want to check it. I'm going to check 161 with 28. So 161 divided by 28 is equal to $5.75. So yep, it works. Hope this helped you out.